Hello, welcome to PiPad Mathematics. I am Professor Lamb, and this video is going to be discussing number rods or Cuisinart rods. It's a number rods app by Brainingcamp, and it's utilizing the concepts behind the Cuisinart rods created by Georges Cuisinart. And what I'm going to do here in this video is discuss a little bit about using concrete objects and pictorial models and equivalent fractions. So what I have is I have a model here, the rods themselves, and we want to model equivalent fractions. Now there's another video just talking about the general construction or modeling of fractions themselves, and in that video there was a little hint at the idea of equivalent fractions. And before we get into that, you got to understand, what does it mean to be equivalent fractions, or to what is an equivalent fraction? And there's often a misunderstanding, a misconception by young students and old students alike. And you have this yellow rod, and I can fit 5 white ones into it. And because I can fit 5 white ones into the yellow rod, therefore this 5/5, if you will, is my equivalent fraction. Well, there's kind of a yes and a no answer to this. The yes is that if your yellow equals 1, then that's going to equal 5/5. So our 1 can be modeled, or can be equal to any value, any fraction, to where the numerator is equal to the denominator. So 1 could equal 10/10. 1 could equal 15/15. 1 could equal 274 274ths. Yes, these are equivalent fractions. I will give that to you. However, the concept of equivalent fractions that we're really talking about here are kind of non-integer, less than 1, greater than 0, or you can also get improper fractions, type of fractions, to where you can establish a unit fraction of sorts, or a fraction in simplest form, and then you can create equivalent fractions by multiplying by a scale factor. That's where we're going with this. Where we're going is that you can take 1/3 and you can multiply it by the scale factor of 2, which would be 2 divided by 2, or that 1 concept, and that's going to equal 2/6. So 1/3 is going to equal 2/6. That is an equivalent fraction, because 2/6 is going to be a equivalent fraction to 1/3 because of the multiplication of the scale factor of 2 divided by 2, or the scale factor of 2. That's where we're going. That's the procedure. That's the knowledge that we want students to obtain, to understand, to be able to regurgitate. But before we can do any of that, we need to build a conceptual understanding that they can see through an area model like this, that 1/3 does equal 2/6. So I'm going to clear out this, and we're going to do a kind of simple, if you will, model, to where we can see that 1/3 equals 2/6. So here's a dark green rod. Dark green rod, we'll call that our 1, equals 1. Then we know that our white rod, 6 of these equal that. So this white rod equals 1/6. And then we also know that our light green rod here equals 1/2. Equals 1/2. And we know that our red rod here equals 1/3, because 3 go into that. Equals 1/3. So with this model, we're going to do a couple things. First thing I want to do is I want to show, like I said, that 1/3, this 1/3 here, equals 2/6. Well, we said or showed that the white rod equals 1/6. So if we fill the area of our red rod with the white rods, we notice that the red equals 2 whites. So each white is 1/6. So that equals 1/6. Let me undo that. 1/6 plus 1/6, which equals 2/6. You have 2/6. So our 1/3 is really equal to 2/6. This model, or this way of modeling, shows students that the red rod was 1/3 of our whole and the white rod was 1/6 of our whole, but we can replace the red rod with our white rods, making the red rod equal 2/6. That's equivalent fractions. And so you can also do an idea of equivalent fractions where 1/2. All right, let's do 1/2, and we want to see that 1/2 also equals 3 white ones. 1, 2, 3, and so because each white one is 1/6, then 1/2 is going to equal 3/6. So we show that 1/2 equals 3/6. Thus, we are modeling an equivalent fraction there. Let's clear all this out. Clear, clear, clear. And we can do that with a variety of wholes. We can go with our orange. If our orange is a whole, then we can do 1/2 equals 5/6, 5 of these. Let me do this. Let me go to our grid. It's going to show this a lot better. Take my pen off, go to the square grid, and we can see that our orange is our whole. So the yellow is going to equal 1/2, but it also equals 5/6. We see that the red equals 1/5, and we see that the purple equals 4. I'm sorry, the purple equals 2/5. So this equals 2/5. And then I started off on a bad example. When I say bad example, I'm trying to find other equivalent fractions with our tenths. And we have our 1/2, and then we have 5/5. What if I did brown as being my whole? Well, the brown equals, if the brown equals 1, then we have our wonderful white rod that's going to be 1/8. And our red rod, which is, you get the 2 in there, 1, 2, 3, 4 times. So the red equals 1/4, but it also equals 2/8. And then the purple rod equals 1/2. So purple equals 1/2. But it also equals 2/4. So we're building and we're showing many different equivalent fractions using these Cuisenaire rods. The idea is, as a teacher of mathematics, you want to allow students to explore these. You want to allow them to come up with their own equivalent fractions and to show you those equivalent fractions, and then later on understand this pattern that when you have equivalent fractions, then you multiply by a common numerator denominator, or a scale factor. That here, if I multiply 1 times 2, then I get 2, and 2 times 2 gives me 4. Here, 1 times 2 gives me 2, and 4 times 2 gives me 8. So multiplying by a scale factor of 2 allows me to generate this set of equivalent fractions. But that is a procedural way using the scale factor, and then this modeling way helps build the concrete understanding of that. So there's a lot you can do with equivalent fractions and with these number rods or Cuisenaire rods, and so I implore all teachers of mathematics to do these things, to explore, have students explore so they can get engaged in the learning process. So I thank you for watching this video. I'm Professor Lamb, and this is PiPad Mathematics.